and welcome to Excellence Academy. For today's class, we'll be looking at the basic rules for naming organic compounds. If I'm given an organic compound, how do I name it? We'll look at that shortly. But before that, let's look at a brief revision from our last class. By the way, if you missed the first video on organic chemistry, simply look at the description on this video, and there's a link there that will lead you to the previous or the first class on organic chemistry. Alright, from the first class we looked at the definition of organic chemistry. We looked at some of the terminologies there, including homologous series, sigma pi bonds, functional group, alkyl groups, and what have you. Alright, so with that idea now, let's look at these two compounds. For these two compounds here, what if I'm asked to find the total number of sigma and pi bond for each of these compounds, and I'm asked to find the hybridization pattern of the circled or the highlighted carbon atom, what do I do? I will start with this first. Let's say I'm asked to find the number of sigma and pi bond here. For this, from our previous class we said for sigma bond that one single bond contains one sigma bond and one triple bond contains what there? One sigma and two pi bonds. So for a triple bond, 1, 2, 3, I have one sigma and also what there? Two pi bonds. So if I'm to count the total number of sigma bonds here, it becomes 1, 2, 3, 4, 5, 6, 7, and 1 here. That makes it 8. So I have 8 sigma bonds here in total. Next up, I'm asked to find total number of pi bonds. Pi bonds only occurs in double and triple bond. So for a triple bond, I have 2 pi bonds. So this becomes 2 pi bonds. Next up, if I'm asked to find the hybridization pattern of this, we said when it comes to hybridization for an alkane, alkane has sp³ hybridization pattern, alkene has sp² hybridization pattern, and alkyne has sp hybridization pattern. This is an alkyne. Why? It has triple bond. So this being an alkyne is because it has triple bond. And for an alkyne, we said the hybridization pattern is sp hybridization pattern. So hence, this compound has a total of 8 sigma bonds, a total of 2 pi bonds, and then this particular carbon is sp hybridized or has sp hybridization pattern. Alright, this one has sp³, of course, it's an alkane. This one too is sp³, it's an alkane. This one is sp, why? It's an alkyne. So this is for this compound. Coming to this, we said for every double bond, a double bond has 1 sigma and what's there? 1 pi bond and 1 pi. So count total number of sigma bonds. My total number of sigma bonds becomes 1, 2, 3, 4, 5, 6, 7. So in total I have 7 sigma bonds. For total number of pi bonds, I can see 1 pi from this. So I'm having 1 pi bond here. And then finally, the hybridization pattern. This is a double bond. A double bond represents an alkene. And we said for an alkene, your hybridization pattern there is what there? sp² hybridization. sp² hybridization. So this has 7 sigma bonds in total, 1 pi bond, and then sp² hybridization. Alright, having looked at this, let's now look at the basic rules in naming any organic compounds. What are the rules? Or if I'm given an organic compound, how can I easily name the compound? What and what should I look out for first before I name the compound? So, there are actually 6 major rules. There are actually 6 major rules in naming any organic compound, but for this class, look at just three. Look at the first three basic rules in naming organic compound for this class, and then in next class, look at the next three rules in naming organic compounds. Alright, so what's the first rule in naming organic compound? The first rule is to do this. Number one, select the longest continuous carbon chain as the parent or the root hydrocarbon. Alright, and then count the number of carbon atoms and then give it this pattern of naming. If I have one carbon atom, for one carbon atom, I'll call it a met. For two carbon atoms, I'll call it an et. For three, call it pro. If it contains four, call it but. If it contains five, call it pent. If it contains six, call it hex. If it contains seven, call it hept. If it contains eight carbons, call it oct. If it contains 9 carbons, call it non. If it contains 10 carbons, call it dec. If it contains 11 carbons, call it undec. If it contains 12 carbons, call it dodec. If it contains 13 carbons, call it tridec. Alright, so that's your first rule. Count your number of carbon, your number of carbon atoms that are continuous. Alright, and then for one carbon is met, for two is et, for three is pro, 4 is but, 5 pent, 6 hex, 7 hept, 8 oct, 9 non, 10 dec, 11 undec, 12 dodec, 13 tridec. That's your first rule. For the second rule, simply identify a functional group. For example, if it's just a single bond, it becomes an alkene. If it's a double bond, it becomes an alkene. If it's a triple bond, it becomes an alkyne. If it contains OH, it's called an alkanol. And then, what have you? Rule 3. Okay, before rule 3, let's use rule 1 and rule 2 to name few compounds. For instance, let me have this. By the way, for every carbon to be stable, of course, carbon has 4 valence electrons. So that means carbon requires 4 more bonding for it to be stable. So for this carbon atom to become stable, I'll have to give this 1, 2, 3, 4. I'll put hydrogen, 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 hydrogen. Alright, so this is now stable. The carbon has 4 bonds. Following the rules there, rule 1, count the number of carbon atoms. I'm having just one carbon atom. For one carbon atom, we said call it a met. So number 1, this is called a met. Rule 1 is called met. Why met? It has just one carbon atom. Rule 2, we said look at the functional group. If it's single bond, double bond, triple bond, OH, or what have you. If I look at this, I'm seeing just one stroke for each of these. So it becomes what there? A single bond. We said single bond are what there? Alkane. Or alkane is the homologous series for the functional group of single bond. Alright, if I combine this with the last 3 names, this gives me met for one carbon and then A for alkane. So this compound is called methane. Number 2, let's say I have so I have an OH, I have this observe that each of the carbon here are balanced. This carbon atom here has 1, 2, 3, 4 balanced. This carbon atom here has 1, 2, 3, 4 balanced. Alright, rule 1 says get a longest continuous carbon chain. For my longest continuous carbon chain, I have 1, 2. So 2 carbon. 2 is what here? Et. So rule 1, this becomes et. Why et? It has 2 carbon atoms. Rule 2, get the functional group. While I'm seeing single bond, there's a kind of functional group that has OH. For OH, we call them what there? The alkanol. It's called the alkanol. If I combine this et with an alkanol, it becomes et and anol. So I'll call this et from this, then anol, yeah? I'm having anol. So this is named ethanol. So this is like your basic idea when it comes to naming organic compounds. We look at the third rule and get other examples. The rule 3, or the third rule, when it comes to naming organic compound is this. For the third rule, simply number the carbon atoms from the end of the hydrocarbon, number the number of carbon atoms in the hydrocarbon from the end, which will give the least or the lowest possible number to the substituent or functional group in the hydrocarbon compound. How do I know that something is a substituent per se? Alright, let's take this example. Let's say I have this 1. Alright, my first task would be to balance all of this. So I'm having 1 here, 2, 3, 4. This one has 1, 2, 3, 4. This one has 1, 2, 3. One more, 4. This has 1, 2, 3, and 4. This has 1, 2, 3, and 4. This has 1, 2, 3, and 4. This one also has 1, 2, 3, 1 more, 4. So I have this compound here. Case 1, count your longest continuous carbon chain. So I'm having 1, 2, 3, 4, 5. Please, mind you, you don't say 1, 2, 3, 4, 5, 6, 7. That will be wrong. Why? They are not continuous. You're only counting the longest continuous carbon chain. That means the carbon chains must be linked by either a double bond, a single bond, or a triple bond. If I look at this, I'm having 1, 2, 3, 4, 5. There's no linkage between this and this. So I'll stop there. For this one, I'm having 1, 2, 3, 4. This is linked to this by this. So it becomes 1, 2, 3, 4, 5 by this count. Count this way, I'm having 1, 2, 3, 4. Count straight, I'm having 1, 2, 3, 4, 5, 6. Hence, my longest is between 5 or 4 or 6. Of course, I'll have 6 as the longest continuous carbon chain. I'm having 6 here. Alright, so this is my first thing there. Rule 1, I'm having 6 carbon. 6, we call this what there? Hex. So it becomes a hex. Number 2 there, we said to look at the functional group. Is it a single bond, a double bond, a triple bond, an OH, or what? This is actually a single bond. I can say just 1 strokes. It becomes a single bond. For a single bond, we said it's called an alkane. So rule 1, 6 carbon, hex. Rule 2, functional group, single bond, alkane. Rule 3, we said number the substituent. In this case, I have a substituent. This is a substituent. Why? Because it's not part of the parent carbon atom. So whenever you're done numbering your longest continuous carbon atom, and you have a particular carbon, such as this, which is not part of the major parent carbon atom, it is now considered a substituent. So this is considered a substituent. Now, question is this now. What kind of substituent is this? If I look at this one here, I have C, that's C. I have 3 hydrogen, 1, 2, 3, CH3. If you watched, or if you're doing the previous class, whose link is in the description there. If you're doing the previous class, we looked at CH3. I think it looks familiar. CH3 is what we call the alkyl group, and we name this as what there? Methyl. So we call this methyl. This is actually methyl. Alright, so we've named this substituent as methyl. Rule 3 says we should number this compound from the end, which gives the lowest possible number to the substituent. How do I number this? There are 2 ways of numbering. The lower numbering from your left hand side to your right hand side, or the upper numbering from your right hand side to your left hand side, whichever order you want to take. Let's start with this one here. I'm moving from the left hand side to the right hand side. So I'm having my numbering as 1, 2, 3, 4, 5, and 6. I'll do my second numbering from my right hand side to my left hand side. It becomes 1, 2, 3, 4, 5, and 6. So observe the numbering. Left to right, that's lower numbering, and then upper numbering from right to left. So name this way. I'm having this. So next up, see my substituent. My substituent is attached to this carbon. Substituent attached to this carbon here. This carbon, if I go with lower numbering, from lower numbering now, I'm having 1, 2, 3, 4. So from lower numbering now, this is carbon 4. If I go with upper numbering, I'm having 1, 2, 3. So from upper numbering, this carbon is carbon 3. And the rule says I'm taking the least number. So between upper numbering 3 and lower numbering 4, which is the least? The least between 3 and 4, obviously, is 3. So I'll go with upper numbering. Hence, I'll discard the lower numbering. So I'll take off the lower numbering. So this one here is off. Lower numbering is taken off because it's not the least. Alright, so I now have this compound here. Alright, so that means the substituent is at carbon 3. So I'm having to name this now. I'll name substituent before the major compound. Please don't forget me. Substituent before the major compound. But this substituent, I'll have to show the position of the substituent using numbers. The substituent is attached to carbon 3. So it becomes what there? 3-methyl. So I'm having methyl. 3-methyl. That means the methyl substituent is at carbon 3. Next up now, name the major compound. 6 carbon was hex. So it becomes hex. Functional group was single bond. That means an alkane. It's called hexane. So this compound is named 3-methylhexane. This is how we name this one here. Alright, take a second example. Alright, so let's say I have this. So I have this one here. So I'll take my longest continuous carbon chain. That becomes 1, 2, 3, 4. Obviously, so I'm having this as longest continuous carbon chain. Next up, look at, so 4 here. 4 is both. So row 1, from row 1, this becomes both. Why? I'm having 4 carbon atoms. From row 2, look at the functional group. The functional group here is single bond. I have just single bond throughout this compound. So it's called an alkane. So it becomes alkane for being single bond. Number 3, I can see something here, which is bromine, a halogen. Bromine is attached to this carbon here, so I'll use row 3. That means I'll put in the numbering, lower numbering and upper numbering. If I do lower numbering, I'm having 1, 2, 3, and 4. If I do upper numbering from right to left, I have 1, 2, 3, and 4. My bromine here is a substituent. Bromine here is attached to this carbon. From lower numbering, this carbon is carbon 3. From upper numbering, this carbon is carbon 2. The least is 2. Between 2 and 3, the least number there is 2. So I'll still go with upper numbering here. Please, this does not mean that your least must always be upper numbering. No. In some cases too, the least number can also be lower numbering. It can go either ways. Alright, so bromine at carbon 2. This becomes, show the position of the substituent. It becomes 2. I will call bromine as bromo. So 2 bromo, meaning that bromine is at carbon 2. 2 bromo, then name the full compound. 1, 2, 3, 4. We call it both. So it becomes both. Functional group single bond is an alkane. It becomes butane. The name of this compound is 2-bromo-butane. Alright, before we go then, one last example, then we'll do something else. let's say I have a compound of this nature, something like this. Right, so let me try to balance this up. This is 1, 2, 3, 4. So this is now having 1, 2, 3, 4. This is 1, 2, 3, and 4. 1, 2, 3, and 4. Right? This is having 1, 2, 3. This makes it 4. 1, 2, 3, and 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 4. 1, 2, 3, 4. Here, 1, 2, 3, and 4. 1, 2, 3, and 4. Right. Let's ask to name this compound. Alright, so we use row 1, row 2, row 3, and we'll see how we can name this. Case 1. Row 1 says get the longest continuous carbon chain. From this, I'm having 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 from this way. If I count this way, I'm having 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 this way. And of course, if I count this way, I'm having 1, 2, 3, 4, 5, 6. So I had 9 straight. I had 10 going this way. I had about 6. 1, 2, 3, 4, 5, 6. I have 6 this way. Obviously, between 9 or 10 or 6, my longest continuous is 10. So I'll take this one here as the parent atom. Longest continuous carbon chain. Alright, so what does it mean? It means that the longest continuous carbon chain can still be branched. In our two previous examples, it was straight. It must not always be straight. That's the idea. Okay, so you can see have a branched figure like this as the longest continuous carbon chain. Next up, I'll look at this one here. I have 2 carbons. These 2 carbons are not part of the major parent atom. So since they're not part of it, you call them what then now? They are now called substituents. Since they're not part of the parent atom there. This is C2, 2 carbon atoms, C2, H1, 2, 3, 4, 5, H5. So if you're there in the previous class, we saw that C2H5 is called what there? 𝗬𝗃. So this is called 𝗬𝗃. Alright. So this substituent is from the alkyl group and it's 𝗬𝗃. Alright, so case 1, longest continuous carbon chain. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We said row 1, 10 is called a deck. Okay? Row 2 gets the functional group. These are all single bonds. They are all single bonds, 1 stroke. Alright, so it's single bond. Single bond is an alkane. So I have deck for 10 carbons, alkane for single bond. Number 3 says do your numbering. Number it in such a way that to contain the least number for the substituents. If I number this way, lower numbering left to right, I'm having 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm having 10 this way. If I number the other way around, upper numbering, I'm having 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So 10 each side. This is my substituent, 𝗬𝗃. 𝗬𝗃 is attached to this carbon. If I look at this carbon very well, if I follow my lower numbering here, from lower numbering I'm having 1, 2, 3, 4, 5, 6, 7. So from lower numbering now, the substituent is attached to carbon 7. If I follow upper numbering, from upper numbering I'm having 1, 2, 3, 4. From upper numbering, the substituent is attached to carbon 4, and we said we take what there? The least possible number. So between 4 and 7, the least number here is what there? 4. So I'll go with upper numbering. I'll discard this. Alright, so discarding this one here, so I can go with upper numbering. I've said before, please, it must not always be upper numbering. It must not always be upper numbering. Alright, so I have this. So we said name substituent first. I will name this one first in naming the compound, but I'll have to show the position of the substituent. My substituent here is ethyl. Ethyl is attached to carbon 4, so it becomes 4-ethyl. So I'm having the name as 4-ethyl. Next up, name the major parent atom. For this, I had 10 carbon atoms. 10 was deck, so we call this deck. And then from the functional group, group 2 is an alkane. So I'll take out the ANE. I'll attach it here. So this compound is called 4-methyl-decane. Right, so I hope you found this video helpful. If you did, please make sure you hit the like button and also share this video to your friends so that they can also learn.